Our facilitator for today is Mr. Daniel. Mr. Daniel is an experienced IT professional with expertise in backup, disaster recovery, server administration, cloud computing, and virtualization. He has over 5 years of working experience helping customers optimize their IT infrastructures, from server updates to upgrades to server migrations to visualization of their environment to conversion of physical servers to virtual machines. He's currently the team lead of the backup and disaster recovery department at Promethean Consulting. He has worked with some of our clients like ICANN, like Carbiton Helicopters, like Cardinal Stone Registrars, and a whole lot more. Yes. So he also has certifications. So he's very certified and very capable of actually taking you. He has certifications in AWS Cloud Computing, Azure certification, acronym certification, compliance and identity certification, Microsoft certified, and a whole lot of other certifications. So without much ado, I'd like to introduce you to our technical expert of today, Mr. Daniel Ian. Mr. Daniel, are you there? Hello? Hello?
Hello? Can you hear me?
Yes, we can.
Okay. So thank you, Paul, for that introduction. Hello, everybody. Welcome to this webinar.
So, Daniel, are you there? Are you still with us?
Yes. Can you hear me? Please, if you can hear me, can you let me know? Hello,
I can
Paul?
hear you.
We can hear you.
Okay. I'll just go ahead. So I said, thank you, Paul, for the introduction. So as not to was here too long. Dive into the webinar. This webinar is going to be in two parts. We're going to have the theory aspect and also the code aspect. Although the part will just be overview. It doesn't touch some physical hands-on. During the talk or presentation, if you have any questions, feel free to drop me and ask, and I'll try my best to answer to your understanding. Okay, so I'm just going to go ahead and share my screen. Please, when you see it, let me know. Please let me know when you can see my screen. Can you see my screen, anybody? Just a little yes will be okay.
Yes.
Okay, that's great. So, like we know, this session webinar is about basics of cloud computing. But we all know that there won't be cloud computing if there wasn't virtualization. So virtualization will be like the main focal point of this interaction. So what we'll be covering today is we'll be talking about what cloud computing is. We'll talk about the different deployment models. We'll talk about the service types. We'll talk about the meaning of shared responsibility model. Talk about benefits of cloud computing. Then we'll dive into virtualization. And at the end of this slide, we would have a little question and answer session, and then we'll do some hands-on lab. Okay, so let's begin. I know we've been hearing of cloud computing. So now, what is cloud computing? But before I define cloud computing, let's talk about the time before we had cloud computing. So before cloud computing became popular, or before it was widespread, organizations used to make use of servers. We all know that. But in order for them to make use of these servers, they had to set up their computing environment themselves. This environment had to include getting a building, like a room, like a server room. They had to be the one to purchase the room or rent out the room. They had to get their servers. They had to pay for the networking of the place. They were responsible for all these things, and they were responsible for power in the location. And this wasn't cost effective, because when they expand, they're expected to also increase their computing resources, which means if they were using one server before and now they've expanded, they had to go purchase more servers. If the total amount of internet bandwidth they were using before was small and they expanded, had to increase the amount of bandwidth they used then. So this was not sustainable. And then some very genius people came up with the idea of why not why don't we decide to provide these computing resources, like we host it, we manage it, we get expertise, the expert hands to manage the infrastructure, the security aspect, the electricity aspect, the network aspect. We take care of it, and then we just provide the access to consumers or customers to make use of it. So that is how the idea of cloud computing came about. So organizations, cloud providers came up like AWS, Microsoft, GCP, Alibaba, Salesforce, all the popular ones we know about. They delved into this new setup and came up with cloud computing. So cloud computing is simply the delivery of on-demand IT resources over the internet. It means get access resources that are on demand, but you access it over the internet. Instead of buying or owning or maintaining all these physical data centers and the rest, just get like a subscription plan to a service provider, make use of all these resources. So you don't worry about don't worry about
Hello?
so
Mr. Daniel.
sorry. Can you hear me now?
Yes, yes.
Can you hear me now? Okay, sorry about that.
Okay, sorry about that.
So like I was saying, you don't have to worry about the maintenance of the data centers, the infrastructure. You have to worry about the security of this infrastructure. Hot hands for maintaining these servers. You don't have to worry about that. The electricity consumption, the what all falls on the service provider. Now, all we have to worry about is being able to access the resources and being able to use the services that service provider are offering us. This is how this is what cloud computing aims to solve. So some cloud services that you could use or you could request for could be computing power or storage or databases or network and so on. And you get to access these resources on an as needed basis. That is, you access it when you need it. I get to pay for it as you make use of it. So you don't get to purchase server that you only need for maybe 1 hour or 2 hours. And then when you're not using it, it's installed. No, you get to use those servers when you need it. And when you're done using the servers, you can turn it off and then you pay for that period when you made use of the servers. Examples of companies that provide this cloud computing service are the popular ones like AWS that we know about, Microsoft that we know, Google Compute Cloud, Alibaba, Salesforce, IBM, OVH, DigitalOcean. There's still more out there, but these are just some of the popular ones. Let's talk about what is the cloud. Also heard people say, I uploaded my data to the cloud. I'm storing my files in the cloud, things like that. But really, what is the cloud? The cloud is simply a term that was coined to describe data center where servers are kept and services that run on the servers are given to clients, their access over the internet. A data center is like a building where there are servers running in them. Now, these servers are running applications or services that customers need to access. And now when we want to access these services, we have to access the services over the internet. Now, this data center is not in the same location as the consumers or the customers. It might be located in another country, in another region, far away from you. When you just hear of the cloud, the term cloud just encompasses all this put together. So you might be using Google Cloud, you might be using Microsoft 365, you might be using Google Drive, you might be using Dropbox. You keep uploading your files to Google Drive, you keep uploading your files to Dropbox, keep downloading from OneDrive. All these services are hosted on the data center somewhere else. When you upload a file to Google Drive, for example, it's going to store on a server in another location. So it's going to store on a physical server somewhere else. The cloud is simply a data center that is located somewhere and can be accessed over the internet. I don't know if you have any questions before I move to the next slide. If you have no questions, I'm going to move to the next slide. Can you confirm if you can still hear me?
Hello.
Yes, we can. We can hear you.
Hello. Please, quick question, please.
Okay. Yes.
Can you hear me?
I can hear you.
Yes, we can hear you.
From your description, it is quite clear and understand, but definitely the cloud provider, just like AWS, definitely they still spend on running their own personal server. Since in the reverse, like before, where people have their server somewhere, which the cost effect is on the high side due to they are highly in demand. So I'm now thinking that is it not still the same thing? Since Google will be the one or AWS will be the one to render the service, is it not still more cost effective? Because if you are uploading the data of probably 1 terabyte in the cloud, and with the rate at which internet charges are growing now, and you have your own personal server in your custody, is it not? I don't know if my question is clear. Is it not still expensive?
So I understand your question. Yes, it's clear. Oh, it really depends on the service you're making use of in the cloud. So for example, uploading the data of 1 terabyte. Okay, let's say you don't want to use any of the cloud providers to do that. If you want to store that yourself, no, it means you have to place storage of 1 terabyte yourself, right?
Yes.
So after making use of the hard drive, okay, for storing this file, and you no longer
Yes.
need the file, you're going to maybe delete the file or something. And what do you do with your 1 terabyte hard drive?
The hard drive?
Yes, the hard drive itself. Just keep it in store.
Okay, for another purposes.
For another purpose. So if you don't want to use it for the next 6 months, it just stays in store, idle. But if you're using the cloud provider, as soon as you finish with your 1 terabyte data upload or download, you unsubscribe from the service and you stop paying. And again, since it's pay as you go, you only pay for the time you make use of this storage.
of the storage. Okay.
As long as you're no longer using the storage, you stop paying. So away from your own example, let's use a server, for example. So imagine if you get one server of maybe 4 gig RAM, 400 gig hard drive, and your keys of it now for an organization. Okay, then you now expand. You now need more computing resources. Does it mean, it means you have to go and purchase a larger server or system, exactly,
Yes.
the environment. So that's how you keep expanding. If your company keeps expanding, you keep purchasing more hardware. And then what do you do with the previous computer with 4 gig RAM? And you're going to shut it down and keep it.
Okay.
Like wasted like you wasted money on that. Now you're focusing on the improved server in your environment. But if you're using cloud computing environment, and you're using 4 gig RAM or 500 gig hard drive of virtual machine in the cloud, and then you expand, you can just quickly scale up, increase the resource on that server to maybe 16 gig, 1 terabyte.
Okay.
And when you no longer need that amount of resource, you can scale down and go back to your 4 gig and 500 gig terabytes. Yeah. So you only pay for the resource you are using. So when you no longer need a large resource on that server, you can reduce it, and then you pay for that reduced resource at that moment.
Okay.
I don't know if that's understandable.
Yeah. Yes, it is.
Okay. If there's no other question, I'm going to move on to the next slide. Yes, when it comes to the cloud, there are various deployment models, and the 3 popular ones are the private cloud, public cloud, hybrid cloud. But there's another one called community cloud, which is not so popular. So let's talk about the private cloud. So this is a model in which the computing resources and the infrastructure are hosted privately within an organization, within an organization's own building or data center, using their proprietary resources. So, like I said, if you're not using any cloud provider like AWS or Azure, it means you want to host your servers privately. And that tells, like I said, you are responsible for the purchase of the building or renting the building. You manage the servers, you manage everything that's that data center. That is your responsibility.
Hello, Mr. Daniel. Are you still there? I can't hear you again. Hello?
Oh? Hello.
Okay, yes, it's more audible now. Yeah.
Okay, sorry about that.
Yeah.
So
I think you just turned on the private cloud. Yeah.
Yes, so I'm going to take that again. So for the private cloud, so you are responsible for hosting your own private cloud infrastructure, from the security parts to the building to the maintenance, the electricity, the power. You are responsible for it. Or you and you alone, you and your organization are the only ones that have access to this infrastructure, not share it with anybody else. Managed and owned and run and used by one organization. It's called private. It is not shared with any other organization. Now, for public cloud, which AWS, Azure, Google, and REST offer, it is a cloud infrastructure that is open to everybody. Instead of one organization making use of this, everybody has access. If you're an organization, you have access to it. If it's just one individual, you have access to it. It is accessible and on demand, and it is accessed over the internet by every organization that wants to make use of it. The difference between private cloud and public is that private is used by one organization, public is used by more than one organization. And then for hybrid cloud, from the name, you can tell hybrid cloud means being able to make use of both the private cloud infrastructure and the public cloud infrastructure. There are some organizations that host some of their services in the public cloud providers, but there are some services that they want to keep in-house. So they might run their own little private cloud in-house to run their software or services, and yet they push some of the other services to the cloud because they have both private infrastructure and then they use public service provider. That kind of setup falls under hybrid cloud. I don't know if there's any question or confusion between private cloud, public cloud, and hybrid cloud. No question, then let's talk about community cloud. Community cloud is basically a private cloud that is used by a small group of or organization. But it's kind of like private cloud, but it is not being used by one organization. It's being used by a group of organization that has like maybe a common principle, and like maybe they're in the same organization. For example, like the banking industry, maybe different banks can come together, and since the bank operates with basically the same principle, they can say, okay, instead of using a public cloud or instead of us having our separate private cloud, why don't we have cloud infrastructure just for the three of us? Let's say GT Bank, Access Bank, and maybe First Bank can just come together and set up their own infrastructure that just they would have access to. So that is their only community, and that kind of infrastructure is called a community cloud. Apart from bank, another organization that might choose to do this can be maybe medical field or a hospital. So hospitals make use of basically almost the same services. So 3 different hospitals or 4 or 5 can come together and decide to set up their own little cloud that just the 5 of them have access to, can make use of that infrastructure. So that kind of setup is called a community cloud. Those are the 4 models of private, public, hybrid, and community. Any questions? If no, is there a question? Okay, if no questions, I'm going to move to the next slide.
I think someone wants to ask a question. JP Graphics, do you want to ask a question?
Not really, not really.
Okay.
Okay, so let's move to the next slide. Okay, then we have something called service types. So service types simply helps us know where the services we are accessing the cloud falls under. So it's not like you go to AWS and say you're looking for SaaS, or you're looking for SaaS platform as a service, or you're looking for infrastructure as a service. No, you just make use of the service that you want to make use of. And then you just have the knowledge that that service you're making use of falls under one of these service types. And there are 3 main types: software as a service, platform as a service, and infrastructure as a service. So let's take software as a service first. For software as a service, it's a method for delivering software applications over the internet and on demand, and typically on a subscription basis. So for SaaS applications, or the service provider, the cloud service provider, is responsible for providing this software for everybody. So they're responsible for the maintenance of this application, software updates, work with fixes, security patching, and the rest. So the only thing that we are responsible for is accessing this application and putting our data on the application. Every other thing is handled by the service provider. I know some of us, we use Microsoft 365, for example. All you have to do for Microsoft 365 is to sign up and start making use of the solution. The only thing that you contribute to that kind of setup is the data you'll be on that platform. So if there's a problem with the solution, you are not the one to fix the problem. The service provider is responsible for fixing that problem. If the server where they are hosting this application is faulty, you are not responsible for fixing that problem. That is the job of the service provider. For the SaaS service type, the service provider is responsible for fixing any issues that has to do with the solution. And all you're responsible for is data you put on this solution. Example of SaaS applications is Microsoft 365, like Teams, Exchange, OneDrive, SharePoint. I'll make use of. Facebook is another example. Instagram is another example. Twitter, Gmail, Google Drive, OneDrive, Dropbox, and numerous others. But these are just a few we'll be mentioning today, but the list is endless. And then let's talk about platform as a service. So for platform as a service, the service provider provides a software platform for you to use in coding or in writing your programs. So platform as a service is basically for software developers and programmers. So if you don't have time to set up your virtual machines or to install OS or to install your SDK for running your programs, you can pick a service like on AWS like Elastic Beanstalk, or on Google like Google App Engine, or on Microsoft app service. You can pick one of them, use it to run your codes. The service provider will be responsible for managing the underlying infrastructure. And all you have to focus on, you, the programmer or service or software engineer rather, all you have to focus on is the code you'll be writing and making sure that that code runs fine. So if there are updates or patches that needs to be done on that platform, service provider does it. So it takes away all that responsibility from you, and all you do is focus on writing your code. Somebody's talking. Hello. Any
Yes, we
questions?
can hear you.
Okay. I'm going to talk about infrastructure as a service if we don't have any questions for SaaS and PaaS. So for infrastructure as a service, which is basically the service type that gives responsibility to the customer. So with this kind of service, the customer is responsible for type of OS they are going to run on the infrastructure. If you want to run Windows, Linux, or Mac OS, you get to decide that yourself. The application you want to run on that platform, you decide that yourself. So what the service provider is going to focus on is providing you with storage, network, servers, virtual environments, and the networking. So if there's a problem with the underlying infrastructure, if the hardware hosting your machine should have a problem, the service provider is going to fix it. If there's any repair, they handle that. If there's any net outage, they handle that. If there's any hardware issue or physical security breaches, they get to handle that. All you get to focus on is handling the system installation, the configuration and maintenance, your network configuration in your virtual environment, the kind of database you want to use, the storage configuration, and so on. You leave all the heavy lifting to service provider, and then you focus on what's there to do. Example of this is AWS EC2. So this is a virtual machine on Amazon. If you want to set up a virtual machine on AWS, you go to the EC2 section for this. Now you the operating system you want to run on your virtual machine. You get to decide the application you want to run. You get to decide the amount of resources you want to give it. Do you want to give it 1 terabyte storage? Do you want to give it 8 gig RAM? Do you want to give it 16 gig RAM? Do you want to give it 2 virtual hard drives? All those kind of things. You get to decide that. But the underlying infrastructure for hosting these virtual machines themselves falls on the hands of the service provider. So the way responsibility of maintaining the infrastructure from you. So you just have to focus on configuring and setting up the virtual machines to be used by you. Those are basically the three differences between software as a service, platform as a service, and infrastructure as a service. Any questions?
Hello? Hello, sir.
Can hear you.
Sir, please, I would like you to say more on platform as a service. Sir, is it like a window on your home system where you write your program or you develop your application personally? I don't really get the explanation, sir.
It's not, when you say like a window, do you mean like on your own laptop where maybe you get to install like a program and then you start writing programs on it? What you mean by
Yeah,
is it like a window?
sorry, like your own interface.
So I don't know if you write programs or codes. So for pass, they provide you with an environment. Let's say you want to write a code with Java, for example. Write Java if you can go to Java or Python. So to provide you with an environment on AWS with all the dependencies and for running that program, so it is already installed. Okay. So
Okay.
all you do is you get an interface where you start coding with your particular programming language. So you don't get to stop yourself with okay, let's say for example, if you're going to write a Python code on your laptop, then even after installing like a PyShell that helps you write codes, you still have to install some programs that will tell you this program is missing on your laptop. You need to download and install. This runtime is missing on your laptop. You need to download and install before you can start writing codes with Python or Java. Okay, but for PaaS on the cloud service providers end, all these dependencies have already been installed and running. So you don't get to install all that. So all you focus on is it gives you a terminal where you start writing your codes. That has to do with Python.
Yeah,
so you don't see away the possibility of installing dependencies.
Okay.
There's somebody raising their hand.
Yeah, sir, can you hear me?
Yes.
Sir, where does function as a service fall into or under? This FAS, I don't know, I just saw it recently.
Yes. So function as a service, well, it's relatively new. There's some programs that run based on, is it should I call it signals? There's this service on AWS called, I can't remember, is it Lambda or something like that? So you have to you configure it, and when something is triggered, okay, when it runs on is this signals or triggers? So when something happens, you write a function. So if something happens, this particular action should be taken. Okay, for example, let's say you are using a virtual machine and you've configured that if the CPU usage should get to 80%, another machine should be spun up to move some of the load from one VM to the other. So something like that. So
the amount of money that the fraudster sends to you, does the mathematics, you see the total. That means that.
Can you mute the mic? It's for function itself. You write like it's, but they call it a function that kicks in when you have a question.
Sorry, I can barely hear you here. I don't know if it's just me.
Hello?
Mr. Daniel. Hello? Can you hear me?
Can you hear me?
Yeah, it's better now. Yeah, thank you.
Yeah.
Okay, sorry about that. So as I was saying, for function as a service, doesn't really fall under any of these three. So with that, you write like a little script, but they usually call it functions. And when a particular trigger is hit, that function runs. I
Okay,
think
okay, okay.
AWS
Yes.
Lambda is example of that.
Okay, so it's on its own.
Yes, it's on its own. It's like it's separate. So
Okay,
it doesn't
okay.
fall into any of these three.
Okay, thank you.
Any other questions? If there's none, I'm going to move to the next slide. Okay, shared responsibility model. When using a cloud computing service, there's some responsibilities that are handled by this provider, and there's some that are handled by you, the customer. So shared responsibility model simply helps us describe these different responsibilities that are for us and for the service provider. So with this diagram, helps us break this down. So we're going to use Microsoft as the service provider. It is light blue. That's light blue. Then there's the dark blue for customer. And then there's shade, half light blue, half dark blue for responsibility that has to do with both service provider and the customer. So let's start from the far right, which is the on-premise part. So if you're the one hosting every cloud infrastructure, every IT infrastructure, and you're hosting it in your own building where you are responsible for everything there, of course, you know that every responsibility falls on you. So it is navy blue. So from physical data center, the networking of the place, the servers you're going to purchase, the operating system you're going to install, everything from bottom to the top falls on you, because now you're the one responsible for hosting this infrastructure. If you are using IaaS, infrastructure as a service, these are the responsibilities that are going to fall on you. The only thing that the service provider is responsible for will be the physical data center, which is building the networking of the place, the hosts. After the host, every other thing that you're going to do under infrastructure as a service is your responsibility. The operating system you're going to install, the network controls, maybe the firewalls, and you're going to configure the applications you're going to run, the people that have access to your virtual machine or to the application you're running on that machine, the devices are going to use to access that service that you set up, whether the mobile devices or the PCs or the laptops that you're going to use to access this platform falls on you. And then the data you're going to impute still falls on you. Hello, can you still hear me?
Yeah, I can hear you.
Okay, just check. Okay. So as I was saying, for infrastructure as a service, underlying infrastructure falls on the service provider, and every other thing from the operating system upwards and the data you're going to impute, the device you're going to use to access this platform, the laptops, the mobile phones, the Android with iOS, with HP, anyone, it depends on you. But the underlying infrastructure is. But for platform as a service, these are the responsibilities of the service provider. You see the physical data center, the network, the hosts, the operating system. Then for the network controls, the applications, and identity and directory infrastructure, that is shared responsibility. So that falls on both you and the service provider. And then every other thing, the account and identities, maybe the users, they'll be accessing your application. Then again, the devices and again, the data you're going to be putting on this platform. That is responsibility. Therefore, software as a service, everything from the data center to the application itself, will be the responsibility of the service provider. Now, both of you will still be responsible for the identity and directory infrastructure of accessing that application. But the accounts, let's use 365 for example. You're using 365. Now you're going to add your users to 365 so they can access it and make use of Teams and make use of Exchange and make use of SharePoint and the rest of that. So you are responsible for creating these accounts and identities. You're responsible for assigning them permissions for accessing this application. That is your job. So if you assign permissions that gives a user privilege that is more than what the user is supposed to have, that is your responsibility. You won't blame the service provider for that happening. And then the devices they'll be using to access the application also, that is the responsibility of customer. And then, of course, the information and the data you'll be putting there is your responsibility. So you only put the data you put there is based on your what you feel you need. You don't have to put confidential or private there. I don't know, is this shared responsibility model, is it understandable? Do you have any questions on this? Can you hear me? Hello?
Yeah. Yes, we can hear you.
If there's no question on shared responsibility model, move on to the next slide. Basically break down the responsibilities. Okay, this is just like a summary of the responsibilities that falls on the...
Hello, Mr. Daniel, you're not audible. I hear you faintly. But yeah, it's better now.
Okay. So this is like a summary of the responsibilities that falls on provider and
Please, you can't hear you clearly. You can't hear you clearly.
Hello? Mr. Daniel, we can't hear you.
Oh.
Yeah, we've not said anything you said in this slide.
Are you hear me now?
Yes, it's better.
Yes, it's okay now.
Okay. So on this slide, this is basically a summary of responsibilities that falls on either ones that falls on you as a customer, and ones that both you and the service provider are responsible. So you are always responsible for the information and the data that you store in the cloud. The devices you use to access this cloud service is the responsibility. Accounts and identities, services and devices within your organization is your responsibility. So for the cloud service provider, the physical data center, the network on the data center location is their responsibility. The hosts in that data center is their responsibility. And then powering of the data center, say they're going to provide 24 hours electricity. That is their responsibility. And then the responsibility that falls on both you and the service provider, sometimes the operating system. If you are using infrastructure as a service, for example, operating system responsibility falls on you. But if you are using software as a service, the responsibility of the operating system is not on you. So sometimes this switches. Also, the network controls. Sometimes it falls on you. Other time it falls on the service provider. The applications themselves. If you are using software as a service, we all know that falls on the service provider. But if you are using infrastructure as a service or there is an on-prem setup, that falls on you. And then identity and infrastructure, sometimes it falls on you and sometimes it falls on the service provider. So this is basically a summary of responsibilities. So you know when there's a problem, you know who to take responsibility. You don't get to blame the other person for something that is or something that is supposed to be your responsibility. And so these are some benefits of cloud computing. I just listed 6, but of course we have more than 6 responsibilities, 6 benefits, sorry. So low cost of ownership. So when it comes to cloud computing, there are basically cost models. We have OPEX, which is operational expenditure, and we have CAPEX, which is capital expenditure. If you're running your own infrastructure on-prem, you usually use CAPEX because now you're responsible for buying or purchasing all the servers. You're responsible for maintaining the building, you're responsible for the networking, you're responsible for the security and all that. That falls under CAPEX. Now, if you're using a service on the cloud, it falls under operational expenditure, which usually is money paid on maybe a day-to-day basis or while the service is running. It's like a pay-as-you-go service. While you are using that service, you get to pay for it. Or if you use the service, paying for that service. That is OPEX. But for CAPEX, to pay for that infrastructure or for that service, it's yours. If you decide to get an upgrade or a larger server, or you need more computers for your organization, you have to purchase extra servers or a bigger server. Now, the ones you purchased before now becomes like a loss because what do you do with them? So usually OPEX is the way to go because you only pay for what you use. If you use a smaller server with smaller resources, you only pay for that. If you increase the resources on the server, you pay for that. And if you reduce, now you pay for the reduced size. You can increase, reduce anytime you like. That is one benefit of using the cloud. Then the benefit of being on demand or highly available is very important. So imagine you want to make use of AWS, or you want to make use of Azure, or you want to make use of Google, and then when you try to create an account or you use of any of the services, it is not available. It defeats the purpose of cloud computing. So being highly available is very important so that each time you want to access a product, a service, or a tool on the platform of the service provider, you are sure that 24/7 is available. So being highly available is a great benefit of using cloud. And then unlimited resource pooling, like I said, you can be using a server with 500 gig storage today, and then tomorrow you decide to use 2 terabytes. You can just switch to 2 terabytes. If in the next 6 months you want to use 10 terabytes, the resources are unlimited. You can switch to 10 terabytes and make use of it. Click of a switch. And then when you want to go back to a smaller resource, you can also do that. So resources are unlimited. You can expand as much as you want. And scalability gives you the ability to increase and decrease resources on your platform. So when it comes to scalability, that is where you hear of things like horizontal scaling, vertical scaling, auto scaling. So this gives you the ability to increase or decrease the resource on the service you are using at click of a button. The same example again still falls under here. Increasing your servers, increasing your RAM on your server, increasing the storage on your server. You want to spin up more servers in your environment. Scalability gives you that benefits to do that. You can simply increase as much as you want, and you can simply decrease as fast as you want. That is a benefit of cloud. If you under the traditional IT infrastructure, if you're not using cloud computing, how do you increase resources on your server? You don't just go online and increase the RAM. You have to like plan ahead. You have to go to the market, maybe meet a vendor to help you purchase more RAM to add to your servers. You have to go to a vendor to help you purchase more storage to add to your servers. How long is it going to take the vendor to respond? How long is it going to take for the delivery to get to your office? You see, all those time is time wasting. But on the cloud, you don't have to meet any vendor to do that. You just go on your platform and switch from 500 gig to terabytes, and you get it instantly. You switch from 2 gig RAM to 8 gig RAM to 16 to 32, and you get it instantly. So that is the benefit of using the cloud. And then there's reliability. Of course, when you're making use of the cloud, you have to be rest assured that the service or the app you are going to use on this platform is always reliable. You'll have to be scared that what if by 5 p.m. of that day, you can no longer access that application, or tomorrow morning, application that was working fine is no longer working fine. Those kind of worries is taken away, because now you know that because of the service provider you're accessing, maybe AWS or Azure, you are rest assured that reliability is the number one priority. You can access this application anytime and in any location that you are. There is no interruption, there is no downtime. And then security. Of course, we know AWS, Azure, and the rest of them, their infrastructure is very secure. You are rest assured that nobody is going to have access to your accounts or the service you're making use of on their platform. You're not going to see that your account has been breached or things like that. They have experts that take care of their environment and prevent bad actors or hackers from getting access to services of their clients or their customers. So this is like a brief list of benefits for cloud computing. There are more, but to save time, I'm just going to talk about the 6. Is there any questions before I go to the next slide? I think we have like 5 more slides to go. And then last can you hear me?
Hello. So you're not. We can't hear you, so Daniel. Hello, can you hear me?
Can you hear me?
Yeah, it's better now.
It's better. You can hear me now?
Yes.
Apologies for the network interruptions. For our time, let's just go on to the next slide and let's talk about virtualization, which is the core topic we'll be focusing on. Virtualization. Sure. This is a technique of creating a virtual or virtual representation of a physical instance. It is a creation of a virtual rather than an actual version of something. That's an OS, a server, a storage, a network, run. So with virtualization, you can create like a replica or a copy of a real life device. But the only difference is that for physical components, you can touch them. For example, your laptop, you can touch your laptop. Run inside your laptop, you can take it out, you can touch it. The hard drive, you can touch it. But for a virtualized instance, you cannot touch these components. So they function as the real thing, but you just cannot touch them. For example, you're setting up a virtual computer. Yes, it's going to have an operating system. It's going to have network. It's going to have storage. It's going to have RAM. All those things. It's going to function like a real computer. You just cannot feel it. This is what virtualization helps us achieve. Then we have virtual host. So a virtual host is a computer that we use to host a virtual machine. So some of us are accessing this webinar using their laptops. So your laptop is like a virtual host or a host machine. And on it, we can host virtual machines. So this example is help understand this. If you are about to host a birthday party, you have a house for a birthday party, okay, and you invite guests to come house to party with you. Now, you that is the owner of the house, you are the host. Now, people come into your house to party with you, those are your guests. You are the host because you are the owner of the house. People coming to visit are guests. So use that example for this. You have the virtual host, which is the virtual machine. And then the machine that you create on top of the virtual host is called the virtual machine. You can either call it a virtual machine or you can call it a guest machine, because it resides on the physical server or the physical infrastructure. Is it clear? The virtual host and the virtual machine description or explanation, is it understandable? Is there any question there or any confusion? Can anybody hear me? Hello?
Hello, Mr. Dan.
Yeah, we can hear you.
Yeah.
No interruption now. I think there's no question for this.
Hello, Mr. Dan. Are you still speaking? It's not audible.
Cannot hear me?
Yeah, it's better now. It's better now.
So I was asked if there was any question. Some people answered there were no questions. Okay, if there's a question, I'm going to move to the next slide. You can still hear me?
Yes, yes.
Okay. So let's talk about a hypervisor. So that for us to create virtual machines on physical hosts, we need a software called a hypervisor. So a hypervisor is a software that makes it possible for us to create virtual machines on physical hosts. So with a hypervisor, you can run multiple virtual machines on one physical host. Now, these virtual machines are going to make use of the resources on the physical hosts, like the RAM, the storage, and the processor. So this hypervisor is sometimes called virtual machine manager. Okay, so in order for us to create virtual machines in the first place on a machine, you don't just go to your physical host and start creating virtual machines. No, you need a solution, a software that is going to help you do that. And that software is called a hypervisor. So you have to run it, and then on the hypervisor, you create the virtual machines on it. And there are two types of hypervisors. You have the type 1 and the type 2. Now, the type 1 is called bare metal, and the type 2 is called hosted architecture. So for the type 1 hypervisor, the hypervisor runs directly on the physical machine. Like you have your physical hardware, and instead of having your maybe Windows 10, or some of us having operating systems, maybe it's of Windows 10 or Windows 8 or Windows 8.1 running on your server. You don't have that operating system. All you have is a physical laptop, and then you have the hypervisor software running on that physical laptop. There is no operating system in that kind of setup. And some examples of that are VMware, ESXi, Citrix, Linux Secure, and the rest of them that are listed here. But for the type 2 hypervisor, there is an operating system. So you have your laptop. Your laptop is running an OS with 10, with 11. And then on that operating system, you have the hypervisor running on it. And then on the hypervisor software, you now have your applications. So the main difference between
And please, Mr. Daniel, we can't hear you anymore.
Listen with me.
I can't hear you, Mr. Daniel.
Can you hear me?
Yeah, we couldn't hear you before, but now we're able
Better
to.
now.
Can you just take the...
Okay, I'll take it from the type 1 again. For the type 1 hypervisor, I say you do not need an operating system. There's no operating system operating the hardware from the hypervisor software. So I use your laptop for example. You have your laptop currently. Your laptop has an operating system running on it. This system can be any version, Windows 10, Windows 11, Windows 8, Windows 8.1. Now, but for the type 1, there is no operating system at all. You just have your hardware, physical laptop, and then instead of an operating system, you have a hypervisor software running on it. Now, on that hypervisor software, you now have your virtual machines running on it. This is why from the second sentence on this slide, you can see there is no operating system from VM. And examples are VMware, ESXi, and the rest listed here. But for the type 2 hypervisor, there's an operating system separating the physical hardware from the hypervisor itself. So you have your laptop, you have an operating system running, Windows 10, Windows 11, and then you have the hypervisor running on that operating system, and then you have the virtual machine running on the hypervisor. Example of that kind of setup is Microsoft Hyper-V, VMware Workstation, VMware Fusion, Oracle VirtualBox, and others. So the main difference between type 1 and type 2 is that type 1 does not have an operating system. Type 2 has an operating system. So from this diagram on the left, for the type 1 hypervisor, you can see you have the hardware, is maybe your laptop. You have the hypervisor, and then you have VM running on the hypervisor. But for the type 2, you have the hardware, you have the host OS. So the host OS is your operating system. You have the hypervisor, and then you have the virtual machine. So basically, the difference between both of them is one has an OS, the other does not have an OS. Please let me know if you can still hear me. Hopefully, I wasn't talking to myself.
Can hear you. We can hear you.
Okay, thank you. Okay, so for type 1 and type 2, is there any question or confusion? Is it clear enough? Okay. So let's move to the next slide. I think basically that is all we have on the theory aspects. Then we can some questions or hello? Hello?
Hello, Mr. Daniel.
We can hear you. We can hear you. Mr. Daniel, we can hear you.
Okay, check it. So that's all we have on the theory aspects. And we can reach the practical aspect. Unless you have questions to ask me. I would like us to do a few practicals on virtualization so we see how it works. You're with me, right?
Yes.
Okay. So
yes, we are with you.
Let's leave the questions for later then. Let's do some practicals. Okay. So these are some of the practicals we'll be doing right now. If you have your laptop, if you can follow along, that's fine. If not, that's also fine. I'm going to do of this setup one after the other. If we still have time, I'll try to round up this in like 30 minutes. So please bear with me. Okay, so before I'm going to be using Hyper-V. Before we can start creating virtual machines or working with hypervisors, we need to enable it on our laptop. Or if we're using servers, we need to enable it on the server. So I'm going to share my desktop. So you can see
Mr. Daniel, we are not hearing you anymore.
Yes, sir. I wasn't talking. I was trying to share my screen. Can you see my screen? Like, what can you see? Can you see? This is if I'm sharing the correct screen.
Yeah, we are seeing your desktop environment.
Okay.
Yes, we are seeing your screen, sir.
Okay. So before we can create before we can start creating machines on our system or our laptops, for those of us using Windows 10 or Windows 11, we need to enable Hyper-V on our laptop. Okay. Before we do that, we need to even confirm if virtualization is enabled on BIOS of our system. I can't really show you how to do that because it means I have to shut down my system to go to the BIOS settings. But we can always check online on how to do that. But after enabling it, you need to check if virtualization is enabled. And on your system, you can go to Task Manager, search for Task Manager on your system. Hopefully, you can see the Task Manager. You go to Performance. You can see CPU, memory, disks, and the rest of it. So we'll go to the CPU part of the screen, and at the bottom right, see virtualization, then you see enabled. So if you're with your laptop and you're following along, you do the same thing. You go to Task Manager, you go to Performance, you go to CPU, and then you check for virtualization, and status should be enabled. Then you can use virtualization on your system. After confirming that, now we need to enable Hyper-V. On Windows 10, you search for turn Windows features on or off. This option, turn Windows features on or off. Click on it, you get this small pop-up. Then you search for Hyper-V. You can see this little checkbox. It needs to be checked. If it is checked, it means you've enabled Hyper-V. And when you check the box, this other sub options will also be checked. If it is not checked, it means Hyper-V is not enabled on your own system. So you need to check it. You click on OK. When you click on OK, it's going to ask you to restart your system. Now, if you restart your system, then you'll be able to use Hyper-V. But if you do that now, it's going to log you out of this session, and you have to join back when you're done. For those of us that already have Hyper-V enabled, after doing that, now what you have to do is search for Hyper-V Manager system. Are you with me? Are you with me?
Yes.
Yes, sir.
Okay. After enabling Hyper-V, you need to search for Hyper-V Manager on your system. Like this, just type on Hyper and you see Hyper-V Manager. So this is the hypervisor we're going to be using with virtual machines. Okay. So I already have machines here, but we'll just quickly spin up one that we're going to make use of now.
Please, can someone ask a question?
Okay. Yes. Go ahead.
Are you going to install the Hyper-V from the zip file, or how do you get the Hyper-V?
Hyper-V is a feature that comes to your Windows system.
Okay, with your operating system.
Yes, it is there already. It's inbuilt. You just have to enable it.
Okay.
Okay, so let's quickly create a virtual machine. So we'll see how it works. So this is my own hypervisor. Okay, I already have this of systems, but I'll create a new one quickly so we see how it looks. Okay, so to do that, on the right side of this window, you can see new. You can see virtual machine. Quickly create a server 2019 virtual machine. So you see how it works. Click on next. Now I'm going to give my virtual machine a name. Since I'm creating Windows Server 2019, I'm going to give it Windows Server 2019. Then I need to choose the location where I want to store my virtual machine. Of course, it has to be stored somewhere on your laptop. So you need to pick a folder on your drive to keep it. So on my system, I have two drives, drive C and drive E. I'm going to pick drive E. I have a folder called virtual machines in my drive E. I'm going to pick virtual machines folder. So when I create this virtual machine I'm trying to create, it's going to be stored in my E drive. Okay, now click on next. I get this option, generation 1 and generation 2. So if I'm picking generation 1, it means
Yeah, Mr. Daniel, you're not, you're faintly audible. It's not that clear.
how about now? How about
It's still a little low.
now?
Yeah, it's better. It's better.
Okay, so like I said, you have to give the virtual machine a name, and then you pick the location where you want to keep this virtual machine. And then on the next page, you select the generation of virtual machine you're trying to create. So if you're picking generation 1, generation 1 supports a 32-bit or 64-bit operating system, and the generation 2 supports only 64-bit operating system, and it has some space. Now, if you generation 1 or generation 2, and you create your virtual machine, you cannot go back to change the generation of the virtual machine that you just created. So when you pick a generation, you know that that is a final step. It cannot be changed. So I have a 64-bit operating system when generation 2. And then I have to give the virtual machine RAM, of course, for it to work. I'm going to give it 2 gig RAM. So remember the units for this is in megabytes. So I've given it 2048. If it was in gigabyte, I would have given it 2 to represent 2 gig. Okay. And then I'm supposed to give it network by picking a network switch. But I'm not going to do that since we're not going to be connecting to anything, just setting up a virtual machine. So I'm going to skip that, leave it at not connected. Click on next. This is where I get to assign the size of hard drive I want to give my virtual machine. I'm going to give it 30 gig. My virtual machine is going to have 30 gig storage assigned to it. Since it's a new virtual machine, I picked create a virtual machine. If I wanted to use an existing hard drive I already had, I would have picked use an existing virtual disk. Or if I don't want to put a hard drive at all, I would have so an attach a virtual hard disk later. I want to give it a virtual hard drive now. So I'm going to choose create a virtual hard disk. I'm giving it 30 gig. Click on next. And it's asking me to install my operating system. So it's telling me install it later or install an operating system. I am going to use this other option because I have a bootable image file already on my system, an ISO file of Windows 2019. These are the ISO that I have on my system currently. I'm going to take Windows Server 2019 for this demo. Click on next. It gives you a summary of all the configurations you've chosen. Then you click on finish. And this is the machine we set up, Windows Server 2019. It's pretty straightforward, but we are not done yet. So we need to turn it on and install the 2019 OS I just attached to it. So I'm going to right click, connect. And I click on start. Can you see this this little pop on my screen? And you press a key to boot from the ISO. If you can see this little pop-up, please let me know.
I can.
Okay.
I can see it.
Thank you. Yes, so we're going to try to install the 2019 OS on this VM right now. Wait, so we will leave everything as default. So not to waste our time, click on install. So when we get to the page where it starts installing, I'm just going to show you another system that was already finished installing. So if I had the product key, I would have inputted the product key, but I do not have a product key. So I'm going to click on, I don't have a product key. And then I get to pick one I want. So if you don't see desktop experience in front of this, it means you're going to be setting up a system that does not have a GUI, that does not have an interface. You will only be able to control that system using commands. But those are for experts. So we're going to use desktop experience, meaning it's going to give us an interface like our laptop, so we can click on things, on icons, and control the system. Okay, you need to accept the terms and the license types. It's a brand new installation. This is the 30 gig I gave my system when I was setting it up. So that is it. Click on next. And it's installing. We're not going to wait for this to finish because it might take a while. So when this is complete, we are going to get this screen.
Yeah. Mr. Daniel, are you still speaking? I can't really hear you. Hello, Mr. Daniel.
Mr. Paul.
Yes, so we didn't hear you for a while.
Okay. I was saying instead of waiting for the installation of the other system to complete, I'm just going to bring up another system that has already completed. We can use that for this demo. Okay. Let's see where this is. This is at 4%. So we can't wait for this to complete. So instead of waiting for this to complete, we use this window. This is an already completed one. When that one completes, we're also going to get a login screen. The only difference is that we're going to set a password that we're going to use to log in. It's other one. So we can't wait for that to complete. Let's use this demo. Just going to log in so you can see how it looks like when you set up a virtual machine. So when you're setting up a machine also on a physical server, this is how it is going to look. The only difference is that now you're setting up on physical server instead of a VM. But in this case, this is a VM. See, it still has everything that your laptop has. That's the desktop folder, downloads folder, documents folder, and the rest. And then you can see the hard drive, 30 gig. But after the installation, of course, it takes space for installing the OS and some OS files. So some space I already used. So this is how to create a virtual machine. Briefly and fast. Those are some things we can do if we're doing we're going further. Okay, any questions about that? Since this is a webinar, I don't want to go deep because there's no time to do all that. I'm just going to show you basics. Let me know if you can hear me. Can you hear me?
I hear you.
Okay. So basically, that's how to set up a VM. This is running, so we're going to leave it. I don't know how long it's going to take to complete. Probably 15 minutes. Okay, so let's do a little practical also before we go. One more hands-on. Before we create a checkpoint. So a checkpoint is simply saving the state of our virtual machine at the point when it's still in its working state. For example, when you create a machine, you can save the state that it is working now, so that in case you want to do like experiment, you want to run an application on that machine, and you're not sure how the application is going to make that machine function, it's going to crash your machine or make it misbehave. So you create a checkpoint, like a backup, and then when you run the application and that becomes faulty, you can always fall back to the checkpoints you created. You can revert back to the last working state of that machine. So let's use this one we just used now as the example. I'm going to connect to it again. Show you how it looks like inside. And then I'm going to create a checkpoint. I'm going to do some changes inside the machines, and then I'm going to recover those checkpoints. I see how it looks. Okay, so this is the machine currently as it is. Okay, I'm going to create, I'm going to add a new folder. I'm going to add a new file, and let me just add one more folder, just for the sake of it. So this is the machine now. Yes.
Yes, someone has a question here.
Okay.
For you. It says, thank you, Mr. Daniel. Can you throw more light on how someone can start a career in cloud computing? Someone has a question relating to that.
Okay. So basically, before you even decide to go to cloud computing, you should have an interest in IT. Basically, cloud computing has different aspects that you want to focus on. The infrastructure part of cloud computing, which has to do with maybe configuration of servers and things like that. You want to focus on the networking parts, where you have to work with, you have to be good with routers, switches, VLANs, things like that. You want to focus on the administration parts, like Azure. Azure has its own path. You are going to the Azure aspect of cloud computing. So cloud computing is kind of wide. So it depends on which area you want to focus on. Then you know where to look at. Let's say you want to go on for Microsoft Azure. There are different paths you can take for Microsoft Azure, which is different from, let's say, Amazon, for example.
Hello, Mr. Daniel. You are not audible. Mr. Daniel, can you hear me? We didn't get some part of the things you said.
Can you hear me?
Yeah, it's better now. It's better now.
Okay, I was saying, so cloud computing is kind of wide. It depends on the area you want to focus on. I say you have the infrastructure part. It gets to work on machines and the likes. You have the networking part, where if you are a network engineer, you get to work with the networking as a cloud provider, like on Azure. You get to work with some VNets, VLANs, and things like that. And then for Azure and AWS, they have their own different paths you can follow. But basically, you have to begin with like an IT support. Like, you need to know how to make use of a computer. You need to be able to work with different operating systems. You need to have an interest in solving solutions. Before you can even decide to say, okay, let me Azure or AWS. So we're going to focus on Azure. They have certification parts you can follow for Azure. If it's AWS, they have their own certifications you can follow for those different platforms. So it depends on which platform you want to focus on. It tells you which certifications you have to take and which resources you have to read and things like that. But if you're interested in the infrastructure aspect, where you have to work with machines, things like that, configurations of servers, you have to be good with the basics, like this. virtualization part, because on the cloud, you also work with virtualized components. So you can always practice, you improve your skill on the virtualization part using your laptop, which is you already have. And then from there, you can then transition to the infrastructure part of the cloud. I don't know if that makes sense to the person asking. Hello?
Yes, thank you. Thank you for that. Thank you.
Any other questions? Hello?
Hello, for now, that's the only question I can see on the chat section. So I guess other people too that are interested can always drop more questions there.
If you have any questions, you can drop it there. So I'm trying to round up in next 15 minutes. So I was going to show you how checkpoints works. Like I said, checkpoint is like saving the state of your virtual machine when it was working fine. So you can go back to it when there is a problem in the future. This is one of the virtual machines. I've created 3 folders, as you can see here. So I am going to take the checkpoint of this machine as it is. It is 3 folders. Okay. If I click on the virtual machine, click on checkpoints, and if you can see, it's creating checkpoints right now. And this is the checkpoint I just created. You can see the time. Okay. So let's say we decide to, I would have said normally for this part, we need to like maybe run a program. And maybe that program is going to make your server faulty, and then you can go back to that checkpoint. Since I don't have a program to run, let's say I delete these folders I just created. You have to do cycle bin to like also delete it. So the files are no longer available anywhere. Remember, I created the checkpoint before I deleted this file. So if I recover the checkpoints, I'm supposed to have those files also recovered. So I'm going to go to the checkpoint I just created. I'll click on apply. I click on apply again. Time and then I'm going to connect to the system again, and then we're going to check if the checkpoint actually applied comes with those 3 folders I created. So this is the recovered point. And you can see the folders I deleted are here. So that's how the point works. And then you can test an application on your system. So if that application is a problem on your system, you can report it.
Mr. Daniel, we can't really hear you.
Oh? Hello.
Mr. Daniel.
Hello, can you hear me? So Paul, can you hear me?
Yeah, it's better now. Yeah, we can hear you now. Yes, it's better now.
Okay, I was saying with checkpoints, you can save the state of your virtual machine the way it was when it was working, so that in future, if you run a program or an application or something, or you delete a file on your system, you can always go back to that checkpoint and restore it, and it brings back everything that was lost. So I used 3 files as an example. I created these 3 files. I did a checkpoint. I deleted the 3 files, and then I applied the checkpoints, and you can see the 3 files are back. So that's how checkpoint works. And one more hands-on before we leave, because I think we've spent so much time here. Okay, let's do what we call a replication. So replication is simply having two virtual machines running on the same host, and then changes occurring on one virtual machine. That change is also being applied on the virtual machine on a second host. Basically, we have two hosts, host one, host two. And then on host one, we have a virtual machine running. But on host two, we do not have a virtual machine running. So I'm going to replicate the virtual machine from host one to host two. Then I'm going to make a change on host one, on the virtual machine on host one. And then we'll check host two if we're going to see that change. So this is useful in production environments. So that if the virtual machine you're making use of crashes or goes down, instead of trying to recover from backup, if you have a backup, you can just simply spin up the virtual machine that you've replicated on another host and continue making use of it. We'll connect to host one. And hopefully you can still see my screen. Hopefully I can remember my password. Okay. Hope you can still hear me. Okay. What is my password? Okay. Time to settle down. So,
Hello, Mr. Daniel, you can't really hear what you're saying.
yeah, I'm not really okay.
Okay.
I'm not turning on my servers at the moment. Trying to turn on the servers so I can show you something. It's taking a lot of time because I have a lot of virtual machines running on this platform. Okay, so waiting for that to come up, which is going to take some time. Let's do something else. Let's do this. I'm going to
Hello, Mr. Daniel. Are you speaking? Yes. Can't hear anything.
Oh, can you hear me?
Yeah, we can hear you now. We weren't hearing before.
Okay. I was going to show do like a replication so we could see how that works, but in time to put up because I have a lot of resources running on my system. So I think I should just stop the call there for now, and then if you have any questions, you can ask me. And I'll try to answer that.
So, Mr. Daniel, someone has a question here. He said, sir, can a data engineer work as a cloud engineer?
A data engineer.
Yes.
The data engineer is like somebody that, like a data analyst, somebody that works with a whole lot of data. I think what the data engineer is. A cloud engineer is like somebody that tends to profile solutions to problems like infrastructure problems. If you want to switch to a cloud engineer, yes. Ask him, because the data engineer is on its own is a whole lot. Can you work as a cloud engineer? Yes, you can. That is like you're already in the engineering field. Yes, it's going to be a whole lot of transition because they are not remotely related. I don't know if that answers the question.
Yeah. Okay. So, if there are any other questions, you can. Okay, I think someone wants to ask a question.
Yeah.
Vivian, do you have a question? Okay, someone is asking a question here. It says, sir, can I schedule a checkpoint to run at a certain interval? Hello, Mr. Daniel, can you hear me?
Yes, I can hear you.
Yes, so.
Can you ask the question again? Sorry.
Okay, I said someone asked the question that can I schedule a checkpoint to run at a certain interval, at certain intervals?
You can do that with a solution, but on Hyper-V, it is set to either run automatically or you run points by yourself manually.
Hello, sorry.
Did you get
that? No, it wasn't audible. I didn't really.
Can you hear me now?
Yes, it's better.
Okay, so I said on Hyper-V, the point is scheduled to run automatically, but you can manually run a point at any time that you want. Get that.
A question said, hello, sir. You hosted the VM on your PC. Can we do this? Can we do the same for an external drive? And what is the implication?
I'm trying to request the same for an external drive. Oh, yes, you can host information on an external drive. But since it's an external drive, the read and write operation, like accessing the virtual machine, it's going to take it's going to be slow because it's an external drive. So if it was your drive on the system, you can access it faster. But if it's an external drive, it's lag, it might drag. So, but yes, you can host it on an external drive. Is that okay? I hope you heard that. Okay.
Yes, we got that. Sir. Are there any other questions? Please feel free to ask. Please feel free to ask if you have any questions before we end the session today. Richard, what are the questions that you have? Can we get people that will just talk about what they've learned so far? Maybe one or two people to talk about what you've learned so far. Is anyone willing to do that? Talk about what you've learned so far.
Oh, if nobody's willing to talk, can I ask questions?
We want to thank you, Mr. Daniel, for this. Yeah, Mr. Daniel.
Yes.
Okay. I think were you saying something?
Yes, I was saying if no one is willing to talk, can I ask questions?
Oh yeah. Well, sure, you can ask questions. Okay, JP Graphics. I think you have a question you want to ask or contribution.
How can someone access this class to understand more?
Okay, we are getting to that. We usually have a physical class because with this demonstration you can see it actually would need you to actually be physically present to really understand. So this is just a demonstration of what you get. So we will get to that. So there's a physical class that you can attend to to learn properly. Yes. So Mr. Daniel, you said you want to ask some questions. Mr. Daniel, are you there?
Mr. Paul, can you hear me?
Yes, I can.
Okay, so you wanted to contribute and nobody was saying anything. So I was asking, okay, like throw out so they can like type the answers to see if they got what was taught.
Okay.
If that is fine. So just some simple questions. I mentioned three cloud deployment models. Anybody mentioned that? One is a public cloud. Let me just add the other two. Let's see.
Private cloud and hybrid cloud.
Okay. Somebody was listening. How about the service types? I remember the service types.
Infrastructure as a service, platform as a service, and those are the two I can remember.
That was good. Then infrastructure as a service.
Platform as a service. The recent one, which is function as a service.
And there's
I can't remember
software as a service.
Okay, software as a service.
Right, that is good enough. And then for us to create a virtual machine, which we need. This we need. Is the name of that software. Anybody?
I didn't get the question, sir.
Sorry, I didn't get the question.
Well, can you hear me?
Yes, I can hear you.
Okay. Yeah. I was asking, in order for us to be able to create virtual machines on our laptop, there's a software that we need to be enabled or to be installed. What is the name of that software?
Hyperversion.
Get you. What did you say?
Hyperversion.
Hypervisor. Yes, so that is the software. You need a hypervisor to be enabled for you to be able to create a virtual machine. So, so like Mr. Paul said, this is just an overview of what to talk about during trainings. We have a whole lot more. I don't know if Mr. Paul will show the curriculum or he has more to say about that, but during the training, we'll cover more topics and more features of virtualization. Mr. Paul, you can take over.
Okay, thank you very much, Mr. Daniel, for that wonderful training session. I'm sure all of us were able to learn a thing or two. Yeah, so can everybody hear me? Am I audible?
Yes, we can.
Hello? Okay, so we currently have a training session. We currently have a physical training session that will be taking place in our office at Lekki in Lagos. So it's going to be a physical training that is going to be extremely practical intensive. So it's from the first time we actually go into the training, we are going to actually be engaging in a lot of practicals. So it's going to be a training that is focused on practicals, extremely focused on practicals. We are going to be having a training that will be 90% focused on practicals. And the training is actually going to give you benefits like we are going to have a certification of attendance for this. And we are now going to have a professional certification that will actually come with the training. That one will be a professional certification that will come with the training. And also, access to paid internship. One specific student that does very well will be given paid internship, after their training, and be paid quite well. And also mentorship. The mentorship program is even the most important thing, but the most important benefit in this training, because the mentorship starts from the first day you actually start class. The tutor is going to actually be making sure that every student is carried along. So there's nobody that is going to be left behind. You are going to be all carried along. You are going to be told the things that you should bring before the training. So once you're in the training, you know that, okay, you have all the requirements that you need for the training. And we are going to make sure that you get carried along in the training. Every time you have the question, the tutor will come back and teach you. So it's going to be, because we are focused on actually creating value. How much value can we create? So the training is also going to give you, the mentorship program is also going to give you access to what's it called, certifications, professional certifications, by AWS, the international big organizations like AWS, like Azure, which you can actually even use to actually work remotely. That can actually help you to get remote job. Tech has actually changed a lot of people's life, and it can actually change your life too if you take part in this training. Now, for the training, the fee for the training, initially, the fee that was set up for the training was about $250, but we decided that because of the conditions of the the country at the moment, we all understand how it's difficult for us to there's inflation and so many other things. So we decided to put the training fee at just 150,000 naira. Now, a person, an average cloud engineer, will be earning about 300,000 naira per month. So if you are taking this training, that means in a month, if you get a job immediately after your training, you'll be able to get double times 2 of what you actually paid. So it's a worthwhile investment. Then, so the training fee is 150,000 naira. Now, even from that 150,000 naira, we'll give you a discount. We'll give you a discount of 30,000 naira for the people for the first 5 people, just the first 5 people that register for this training and makes payments. The details of the training will be in the chat, the chat section. So so the training is going to be, so we are going to be giving you a 30,000 naira discount. 30,000 naira discount. This 30,000 naira discount is just for the first 5 people, and it's just for 48 hours. Just for 48 hours, because even the 150 is already very cheap. Now, giving you further 30,000 naira discount, that means you just be paying 120,000. You just be paying 120,000 if you actually pay for tomorrow. The training is going to be taking place at our office at what's it called? Chief Collins, Lekki Phase 1. 21 Chief Collins, Lekki Phase 1. So you can always come visit us. You can always come check up on us. We are a very credible organizations, like I'm sure you've seen it from everything that we've been talking about. We've worked with so many organizations, and we are not just people that are just talking and training you. As we are training you, what we are actually training you on, we are actually offering it as support to organizations, and these organizations are paying a lot of money to get the support that we are offering them. So people that are interested in the payments, can just click on the link. The link has been posted here, so you can check out the training, and if you're interested, you can pay for the training. Now, we understand that it's not everybody that will have the 120,000 at hand, but if you don't have that, we still have something for you. We have instrumental payment plan. Because we know that you might not be able to get all the money at once. So we have an instrumental payments plan for the training. Now, this instrumental payments plan will be discussed with just people that are interested in taking the training. So if you're interested in taking the training, a number is going to be put here, a WhatsApp number. So just make sure you reach out to our WhatsApp number. So we'll be communicating with you via WhatsApp, and we also put our official email address there. So in case you want to reach out to us via email, you can reach out to us for that. So if you're interested in getting the instrumental plan, please reach out to us via WhatsApp or via email. the details are going to be put in the chat description. Yeah. And also for the certificates that you'll be getting now, it's just people that are available that will be getting the certificates, because every certificate we give is carrying our name. So it has to actually affect that, okay, this person is certified. This person actually did this. So it's going to be just for people that are available at the moment are going to be the people that will be getting the certification. Now, for the certification, there's a form that you need to fill to get the certification. It's going to be put in the link description. So once you fill that form, we'll be able to have your details so that we can use it to process your certification. And it's going to be an e-certification. So that e-certification, you can put it on LinkedIn, you can put it on different platforms to show that, okay, you've started your journey in cloud computing. I really appreciate everybody for joining this session. Thank you all. Thank you all for joining this session. I'm sure all of us are excited about transitioning to tech, and I'm sure that everybody has learned a thing or two from this particular training session. So we really appreciate you for coming, for spending your time with us. We started around 11, and this is almost 1. So spending 2 hours, that's a lot of time. So spending that amount of time with us, we really appreciate you for that. So thank you everyone for joining this training session. So that will be all. Are there any questions before we close? Are there any questions?
On the link for the certification, there's no further link when it was clicked to fill the form. Just notification for going to the form, but there's no link to the form.
Okay, there's no link to the form on the certification. Have you clicked on the link?
Yeah.
What are you seeing? What are you seeing?
I'm seeing congratulations something. Let me try again.
Okay, did you click on the start? There's a button you're meant to click. Or maybe we'll just put the other.
The section will begin automatically when the post starts. So it's not yet available for filling. So there's nothing like start.
Which link are you talking about, sir? Is it the training link?
The certification link.
Oh, certification link. Okay. Okay, so the certification link is that we would post another certification link so that you can use that. But yeah, let's. Okay, so you can always try it. We've posted another one, so you can try this new certification link. So this one should go through just to.
Oh yeah, this one is going.
Yeah, just to have your details about. Yes, just to have your details about the training experience, and also get you access to the free certification. Yeah, so are there any other questions before we end it? Close the session. All right, so thank you everyone for joining us. Have a wonderful day.